I'm meteorologist Serena Arnold, and the first major tornado and severe thunderstorm outbreak of the season is going to be happening today, Friday, March 14th, and tomorrow, Saturday, March 15th, through the Midwestern United States. Now, people who live there have definitely heard a lot about it and know a lot about it, so let me fill you in on what's going on. It is this area of low pressure that's going to be bringing a tremendous thunderstorm risk here tonight and through tomorrow, then as well through some of the more southern states. And it's going to eventually move its way through New England. We're going to see some rain showers and possibly a couple rumbles of thunder on Monday. But this storm is going to wreak havoc through the weekend. Storm Prediction Center, yet another part of NOAA showing that there is a moderate risk of severe weather here throughout the central United States. If we look categorically, an incredibly high tornado percentage in southeastern Missouri, northeastern Arkansas, western Kentucky, Tennessee, southern Illinois, northern Mississippi. High winds and hail are also a potential for what we're going to be seeing today. For tomorrow and Saturday, that risk moves a little bit further to the south and to the east, and seeing once again a tremendous area of where we have to be concerned about tornadoes from Louisiana through Georgia, as well as high winds and the possibility of hail. Come Sunday, this line is going to be moving further to the east. We're going to start to see the degradation. We're not going to have all the ingredients we need for the super severe weather, but definitely going to be expecting some strong thunderstorms through the mid-Atlantic and southern regions on Sunday. And like I said before, come Monday, probably definitely rain showers and maybe even a few rumbles of thunder for the northeastern United States on Monday. Now, when you read the National Weather Service summary, also a part of NOAA, they talk about significant tornadoes, widespread damaging winds, and large hail are likely. This is where it's incredibly important to know the difference between a watch and a warning. So if you get put under a tornado watch, it means all the conditions are there, so it could happen. If you get put under a tornado warning, it means it is happening. And the reason this severe weather happens, and we can forecast this really well with meteorologists scattered about the country as a part of NOAA, is because we're looking for some key ingredients, and that is shear, lift, instability, and moisture. Wind shear is when you have wind speeds that change direction and speed with height. So down at the surface, you'll have southerly winds, and they will get stronger as you go up in the atmosphere, and they will rotate to more of a westerly direction. That creates this kind of a profile, which allows the air to rotate. This creates supercell thunderstorms, which are the storms that can create significant tornadoes. So winds at the surface are coming from a nice, strong southerly, maybe even a southeasterly slight direction. And very strong and from the west when you get up into the higher elevations. Also notice this is where you're having sort of a jet stream max. This is where those critical radio weather balloon launches that are going away are absolutely critical. These are the most important piece of severe storm forecasting. So we can see in the hodograph this curve, which indicates it's going to be right for tornadoes, because as we see, we go up in elevation, the winds are definitely shearing, increasing with speed. This is a picturesque tornado setup. The next critical ingredient is lift, and that is going to be warm surface temperatures at the bottom. So the sun warms up the ground and causes air to start rising, and the surface temperatures are definitely going to be allowing for that. Looking at temperatures in the 70s and 80s, that is our lift ingredient. Instability means allowing that air to keep on rising once it starts going off, and this creates these updrafts for long, prolonged, significant tornado-producing supercells. We can get that in a multitude of ways, and they are all coming together for this setup. One, you saw the jet stream maxima, and that creates divergence up top of the atmosphere. Because that jet stream is moving so fast, it actually creates a void behind it, which means air has to kind of upwell from down below to fill that in, and so you get natural instability. You also have this tremendous area of low pressure. As my readers from the weather story that I wrote will understand, low pressure creates lift because imagine high and low pressure are columns of air. If you were to connect these with a straw, this would come down and this one would go up because they would want to balance out. And the same thing happens in our atmosphere. So low pressure automatically creates rising motion. And the last thing we need is moisture. And boy, do we have that with these dew point temperatures in the 60s and approaching 70s. Obviously, we need that moisture in order to provide condensation, which makes the clouds. But there's another really important part about moisture. You see, the air in the atmosphere is relatively dry as long as there aren't clouds present. Let's just go ahead and make that assumption for right now. And so dry air cools at about 5 degrees Fahrenheit per 1,000 feet you go up in the atmosphere. Moist air, condensed air, clouds, condensation cools at a much slower rate at like 2 to 5 degrees, depending on how dense it is. That's how quickly it cools with every 1,000 feet. We all know that warm air rises. So now what I want you to do is picture an atmosphere where, say it's 20 degrees at the surface. We're just doing simple math. You go up 1,000 feet, it's 15 degrees. 1,000 feet, it's 10 degrees. We understand that. Once you have this condensation created, which you're going to get at the surface very quickly with these conditions, this also rises. Now it's cooling at a lower rate. This is only cooling at about 2 or 3 degrees per 1,000 feet. So as it goes up in the atmosphere, the cloud is generally warmer than the air around it, which causes it to keep rising as it falls into cooler air, relatively speaking, and it rises faster and faster and faster. This is convective available potential energy, or CAPE. This is the hidden secret energy that storms have, and this amount of CAPE lets us understand how much energy is there, how fast these clouds are going to be rising, how strong is that updraft going to be, and these are critical ingredients for significant tornadoes. So there's the setup and how it works. You seriously just had Severe Storm Weather 101, and I hope you appreciate your National Weather Service because they figure all this out for you. If you don't want to do this, click on the link in my profile and let's help save NOAA.